Okay, Chem 20, Chem 20 ABs, we're on to the harder part of stoichiometry. That is mass to mass. It's really only one or two steps more, but let's get to it. I just gotta find my smartboard pen. Oh, it's in my pocket. Okay, so the last couple videos were on mole to mole and then mole to mass or mass to mole. Now we are going from a mass of a substance to a mass of a substance. So mass and mass means we need two molar masses, right? Because mass and molar mass go together. The setup is exactly the same, right? Okay, so here's the reaction given to us. It's a little bit easier. We get a balanced reaction. It says 31 grams of silver metal reacts with magnesium nitrate. What mass of magnesium will be produced? Right, if you're not given the reaction, we need to write it. Now let's write down everything we know. 32.1 grams of silver. Okay, it wants us to solve mass magnesium. So we're comparing these two. Then we need our mole ratio. So we have 2 moles silver and 1 mole magnesium. Now, as I said, we need mass and molar mass. One thing that might be kind of confusing that I didn't mention in the previous videos was that the balanced coefficient doesn't affect the molar mass. That 2 doesn't mean that I multiply the molar mass of silver by 2. It's everything that's after the mole, after the balanced coefficient, that affects molar mass. So the silver molar mass is just silver on the periodic table, which is 107.87 grams per mole. Okay, now to keep this straight, that's grams of silver per mole of silver. Because we're solving for mass of magnesium, I need the molar mass of magnesium, which is 2431 grams per mole. And that's grams magnesium per mole magnesium. Okay, so we've got everything listed. Now, what does the question want us to solve for? Well, it's wanting us to solve for grams magnesium. So I hunt around and try and find gram magnesium. There it is. It's in the molar mass. So guess what I start with? I start with the molar mass. Okay. 2431 grams per mole. Now that's grams of magnesium per mole magnesium. Perfect. Okay, once I use that, I can't use this variable anymore, right? Or this piece of math data. Okay, now I need to get rid of moles magnesium, right? It's on the bottom. So where's my moles magnesium? Oh, there it is. It is in the ratio. So I'm going to have to flip that to get it on top. So I'm going to go 1 mole magnesium over 2 mole silver. Cancel, cancel. Okay, once I use that, I used it up. Now I've got moles of silver on the bottom. I have to find mole silver. Oh, there they are. They're on the bottom of the molar mass. What do I have to do to get it on top? Flip it. Mole silver goes to the top, and 107.87 gram silver goes to the bottom. Moles cancel. Okay, now I've got gram silver on the bottom. So I'm going to use this to cancel it out. 32.1 grams silver over 1. Grams cancel. Look at that. Awesome. Now, as things get a little bigger, you're going to find these are the numbers that I have left on top, right? So I'm multiplying those together, and I'm going to divide those by these 2 on the bottom multiplied together. So what that might look like on a calculator is you could go brackets 231 times 32.1 close brackets, divide by open brackets 2 times 107.87. It's just to keep the 2 separate, because if you don't do that, you may wind up dividing these 2 numbers and then getting a crazy wrong answer. So remember, the top is multiplied and the bottom is multiplied, and then we're dividing those 2 numbers on top and bottom. Okay, so it's 2431 times 32. When I cheat a bit, I go divide by. I don't put brackets around the first bit on my calculator because it can do it without brackets. The second part, I do put brackets around. Then I go bracket 2 times 107.87, close brackets. And to 3 sig figs, I get 3.62 grams, mass to mass. So the only thing that's different is we have now 2 molar masses, where in the mole to mass or mass to mole, we only had 1 molar mass. If you're given mass, you need molar mass. So that's why we are having molar mass. Okay, a little bit tougher. Not given the reaction, we have iron 3 oxide. Okay, iron 3 oxide reacts with carbon monoxide. So iron 3 and oxygen, 3 plus 2 negative gives me a 2. That's a screwy looking 2 and a 3. Okay, and that reacts with carbon monoxide. And that produces solid iron and carbon dioxide. This is kind of a screwy one to balance, I think. So we got 4 there. What if we put a 2? What if we put, is that going to work if we put a 2 there? No. So we got 4. What if we put a 3? Yeah, I think if we put a 3 there, that gives me now 3 carbons. So 3 carbons, and that gives me now 3 oxygens plus another 3 is 6. And that gives me 6 oxygens. And then I need a 2 here to balance out the iron. So it's a little screwy one to balance, but we got her. Okay. What mass of iron 3 oxide, okay, what mass is a question mark, okay, is needed to make 100 grams of iron? Okay. So 100, 4 sig figs, grams of iron. So what goes with mass? Molar mass, right? So we need the molar mass of iron oxide, iron 3 oxide, 55.85, and there's 2 of those, and 3 oxygens. Excuse me, coronavirus. 159.70 grams iron oxide per mole iron oxide. Okay, and I need the molar mass of iron. Remember, this 2 balance coefficients do not affect molar mass. So I just need 1 iron, 55.85 grams per mole. Okay, what am I forgetting? Mole ratio. It's so important we put it in a box. We are comparing these 2 entities. I don't know, just for fun, let's go 2 moles iron over 1 mole iron oxide. Maybe that's going to come back to bite me. Maybe I didn't flip it right. Okay, so what are we trying to solve for? We're trying to solve for grams of iron oxide. Okay, so we hunt for that. No. There it is, molar mass. What's similar between the last 2 problems? And they're similar in that we always start with the molar mass of the substance we're solving the mass for. Okay, 159.70 grams iron oxide per mole iron oxide. Okay, good. Once we use something, we can't use it up again. Now we have to use moles of iron oxide. I'm going to have to flip this ratio. Get that on top. 1 mole iron oxide over 2 mole iron. So that cancels. Can't use that again. So I got to get rid of moles of iron, and I have that right here in the molar mass. I've got to flip that though. So mole iron. If you don't like, you can put it in 1 there. Okay, 55.85 grams iron. Okay, cancel. And then I can use the 100 grams of iron to cancel out the iron. Boom. Okay, so once again, I have 2 numbers on top and 2 numbers on the bottom. So I would go 159.7 times 100. Okay, that's not going to affect your calculator, but divided by brackets. 2 times 55.85. Close brackets. That's what I would do. Okay, so 159.7 times 100 divided by 2 times 55.85. Close brackets. Perfect. Okay, 2. Oh man, this is kind of screwy. We got to go to 4 sig figs. If we go back up, the only number we're given is this one. Okay. Yes, the molar mass has different, but the molar mass is not given in the problem. We have four sig figs to round to. I get 142.97 yada yada. Now I've got to keep all four of these digits, and that 7 rounds that. So I wind up with 143.0 grams. Okay, so this is mass to mass. You'll notice that both mass to mass problems start with the molar mass. And that's true. That's going to be true for every mass to mass stoichiometry problem. You start with the molar mass of the substance you need to solve. All right. So that's been a crash course of the 3 different types of gravimetric stoichiometry. So have a go at the problems in the assignment. Please come to the Google Meets if you want to go over some more problems.